Alright, I wanted to try and do a quick video of the things that I went through on the Zoom meeting today in case you missed it. So I first went over the first fundamental theorem of calculus, which basically just says that the antiderivative, which is this, of a function is basically equal to its antiderivative, so big F, of the top value minus the antiderivative, so big F, of the bottom value. And that's the first fundamental theorem of calculus. And so this antiderivative, though, is also the area under the curve. So we can apply that to any function. So here we have f prime. And so what's the antiderivative of f prime? The antiderivative of f prime is just f, plug in the top, minus plugging in the bottom. And then again, just to check for understanding, when you take the antiderivative of a definite integral, what's the antiderivative of g triple prime? Well, it's the second derivative that you go back to. Right? So that's the first fundamental theorem of calculus. All right, so let's do one more, but this time I changed the limits of integration. So what's the antiderivative of little f? That would be big F, plug in the top, minus big F, plug in the bottom. All right. So then I asked everyone to take the derivative of both sides with respect to x. So on this side, if I'm taking the derivative with respect to x, I'm taking the whole derivative of an integral. So from a to x, f of t dt. And that just stays like that on that side. And then we say, okay, let's take the derivative of this big F, and that would become little f again. The derivative of the outside of that would be little f of x. Take the derivative of the inside, which is 1, minus the derivative of this would be little f. Keep the inside the same, take the derivative of the inside, and the derivative of a with respect to x is 0. So in general, we can summarize it like this. We would say d dx, the derivative of any integral, is really just the same exact function where you plug in the top minus plugging in the bottom. But in this case, you have to take the derivative of the inside of both. The derivative inside of x is 1. The derivative of a would give us 0, so it turns into nothing. So really, we just leave it like that. So this is what we call the second fundamental theorem of calculus. So you could just write second FTC. All right, so let's do an example of that. All right, if I asked you to find the definite integral of this, you would have to use u substitution. This is 2t plus 7 to the 1/2 power, and you would add 1 power divided by the new power. And then plug in the top, which is x, then plug in the bottom, which is 4. But here instead, I'm going to ask you to find the derivative of g, meaning find this derivative. So we're really taking the derivative with respect to x of this. All right, so how do we take the derivative of an integral? The function just stays exactly the same for both top minus bottom. And then you plug in the top, so the top is x, and then times the derivative of the inside of that function, which is just 1. Minus the bottom, so the bottom is 4, so we're going to plug in 4, take the derivative of the bottom, which is 0. So anytime you have a constant, it turns the whole thing into 0. So g prime of x equals this here. Okay, this is an example that I just came up with that was different than the Zoom meeting. So those of you that were there, this would be a different type of example. If I asked you to find the derivative of this integral, right? So by taking the derivative of an integral, the function stays the same for top minus bottom. And so all you have to do is plug in the top and then take the derivative of the top. And then you need to plug in the bottom and then take the derivative of the bottom, which is negative sine x. So that's the derivative of the integral. Could you do it the long way? What do I mean by the long way? The long way, I mean, could you actually take the antiderivative here? You could say, okay, that's the ln of t, right? And then ln of t from cosine x to x cubed, and that equals ln of x cubed minus the ln of cosine x. And then if I ask you to take the derivative here, right, derivative of that answer, that derivative would turn into 1 over x cubed times 3x squared minus 1 over cosine x times negative sine x, which is exactly what we got here. All right, so this bottom way is the long way, taking the antiderivative, plugging top minus bottom, then taking the derivative, because we're really taking the derivative of the integral here and taking that shortcut. All right, then we talked about how the derivative of the integral and the fundamental theorem of calculus the fundamental theorem of calculus relates to graphs of f prime. Sometimes they give you the direct graph of f prime, the derivative graph, but sometimes they give you a graph of a function, f of x. But then they'll also give you this statement here, which says that g of x is a new function that's defined by the integral from negative 2 to x, f of t dt. So what they're saying is, my new function g of x, the y values are equal to the area under the curve of my function, where my baseline, my left limit, is negative 2. Well, what if we just took the second fundamental theorem of calculus and applied it to that? Well, that means we would take the derivative of the left side, and then we would take the derivative of the right side. So what's the derivative of the right side? Well, the derivative of the right side would be, function stays the same, plug in the top, minus the bottom, but the bottom is 0. So they like to do this a lot, where they give you this, and you need to make sure that you're able to understand where this comes from. So they gave you the graph of f, but since f is equal to g prime, they've also really given you the graph of g prime. So the graph of a derivative. And so from there, then you can make all of these conclusions about where is the graph of g of x have a minimum, a maximum, where does it concave up, concave down. What you do is you always say, like, let's say we want to know where g of x is increasing. You would say g of x is increasing when g prime, which is equal to f, is negative, because it's where it's below the x-axis. Right? If you have more questions, again, email me. I hope this helped. I'm sure there's Khan Academy on this, probably lots of other videos, but that's pretty much what I went over in the meeting this morning.